Okay, so we are looking at lab 8B. We're taking isopentyl alcohol and acetic acid and generating isopentyl acetate under acid catalyzed conditions. So in our vial, we've already prepared isopentyl alcohol, 800 microliters, 1.5 milliliters of acetic acid, 4 drops of concentrated sulfuric acid, and 100 milligrams of silica gel beads. So we're then going to heat this mixture. We have it set up with a water condenser and a drying tube, and we are going to heat this mixture to an elevated temperature of 160 to 180 degrees Celsius for 1 hour. We're going to allow this mixture to stir, and that will help facilitate this transesterification process. We'll then be able to isolate our product first via extraction to remove the acidic component, followed by distillation to isolate the desired isopentyl acetate product. The isopentyl acetate product has quite a distinct smell. It's often used as an additive which has a banana-like smell. So we're going to allow this mixture to continue to heat, and once it reaches the target temperature of 160, we'll allow it to heat for 1 hour. So our reaction has completed heating for 1 hour. So now what we're going to do is we are going to allow this mixture to cool to room temperature, and then we'll isolate our product from the acid additives via washing with sodium bicarbonate, and then from there we'll concentrate off our organic layer, and then we'll isolate the product via distillation. So we'll resume once the mixture has been allowed to cool to room temperature. Okay, so our reaction mixture has cooled to room temperature, and if you were here in person, you'd be able to clearly smell that characteristic banana smell of our product, isopentyl acetate. So now what we're going to do is we are going to add 0.5 milliliters of diethyl ether to our solution. Okay, so now what we're going to do, now that we've added our diethyl ether, is we're going to extract our product with 2 milliliter portions of sodium bicarbonate, 5%. It's important that you add the sodium bicarbonate very slowly. And as we can see, the evolution of gas as the sodium bicarbonate reacts with our excess acid to generate carbon dioxide. We'll add a little bit more of our bicarbonate as required. And what we're going to do is we're going to subject this mixture to vortex mixing in order to allow our layers to mix. So we'll resume after the vortex mixing has been completed. Okay, so what we're going to do now is we're going to carefully remove the aqueous layer. Keep in mind that the aqueous layer is going to be on the bottom because we have a solvent of ether. Okay, so we've removed our aqueous layer. So now we're going to repeat this process with another 2 milliliter aliquot. Going to repeat this process with another 2 milliliter aliquot of sodium bicarbonate. What we're going to do now is we're going to subject the layers to vortex mixing, and we'll resume once that process has been completed. Okay, so we have our reaction mixture, and just as always, we're going to remove our aqueous layer. Okay, so from there, now what we're going to do is we're going to rinse with a 1 milliliter aliquot of water. Just like always, we're going to mix our aqueous and organic layers, and we'll resume once the mixing process is complete. Okay, so the mixing process is complete, and now we're going to remove the aqueous layer. We're always saving our aqueous layer until we're done. Okay, so now what we're going to do is we're going to dry our reaction mixture. We're going to dry our organic extracts with sodium sulfate. So let's add the sodium sulfate, and we'll resume once that's complete. Okay, so we finished drying our sample. So now what we're going to do is we're going to transfer our organic layers that have been dried. We're going to transfer these dried organic layers into a 3 milliliter conical vial. Okay, so now what we're going to do is we're going to add a boiling stone to this conical vial, and we're going to evaporate off the ether under a stream of nitrogen. Okay, so as you can see, our organic layers are sitting in a sand bath, and we're going to evaporate off the ether under a stream of nitrogen gas. So let me showcase that. So we'll continue this evaporation process, and we'll resume once we've completely removed the ether and we're ready for our distillation step. Okay, so we've evaporated off our diethyl ether, and now what we're going to do is we're going to distill our sample using a Hickman still. So I have already pre-assembled our distillation setup. So we have our full distillation rig with our vial with a boiling stone, our Hickman still, and we have an air condenser. And what we're going to do is we're going to load this onto our heating mantle. Okay, so we have our whole setup secure. And now what we're going to do is we are going to distill our product at a bath temperature of 170 to 180 degrees Celsius. So we're heating our reaction mixture with our boiling stone, and we'll be able to collect our product in the still of our Hickman still. So we'll carefully observe this distillation taking place, and then we'll record our yield of collected product after we isolate our product via distillation. So we'll resume once our sample begins to distill over. We're currently at a bath temperature of 165 degrees Celsius. And so our product will begin to distill over and collect in the Hickman still head. So as we can see, our reaction mixture is beginning to reflux, and over time we'll slowly begin to see the passage of our product from our distillation pot into the Hickman still head. And we'll resume once we start collecting product in the Hickman still head. So our product is slowly distilling over. We could see our product slowly beginning to climb up our distillation column head, and we'll slowly begin to collect our product in the Hickman still head. We'll resume once we start to observe product collecting in the Hickman still head, and we'll resume once we can begin to start transferring our product from the Hickman still into a tared 1 gram vial. So we're continuing to distill our product over. It's still passing up the distillation column, and we're slowly beginning to collect product in the Hickman still head. We'll resume once we start observing a large amount of product collected in the Hickman still head. So we're slowly beginning to collect product in our Hickman still head. We'll continue this distillation until we've completely distilled over the majority of our product. So as we can see, we're beginning to collect liquid product in the Hickman still head. Okay, so our distillation has gone to completion. So what we're going to do now is we're going to cut the heat, and we're going to carefully transfer our product to this tared 1 gram vial. Well, that's a very strong banana smell. So we've isolated our purified product after distillation. So we've isolated our isopentyl acetate. We'll then be analyzing this compound using solubility tests, chemical tests, and we'll also take an IR spectra. The results from the chemical tests and solubility tests will be posted on Canvas, as well as the IR and NMR spectra. From here, I would like you to record the mass of isopentyl acetate that we isolated after purification at the end of this lab, and from this mass value, you can calculate the yield for this reaction. So from this, and including the data provided on Canvas, you have all the information you need to complete your report for Lab 8B.